of, I'm moving towards the covalent bond now. So my topic for today is covalent bonding. Let me share. Moving towards the covalent bond right now. As we have already discussed the three evidences of the ionic bond, now we are moving to covalent bond, and we'll see what is a covalent bond. So keep this definition in your mind. A covalent bond is a bond which is made between non-metals. It can be between atoms or can be between the group of atoms. Okay. A covalent bond, a strong force of attraction, and it is caused by the electrostatic force of attraction between the bonding shared pair of electrons and the two nuclei. Yani, if this is nucleus number 1 and this is nucleus number 2, okay, nucleus number 1, nucleus number 2, here this is the shared pair of electrons. So the force of attraction between this nucleus and the shared pair of electrons and this nucleus and the shared pair of electrons, okay. So force of attraction between this nucleus and the shared pair and this nucleus and the shared pair of electrons. Keep this in mind. So it's a bond which is made between non-metals, atoms or group of atoms with a strong electrostatic force of attraction between the shared pair of electrons and the two nuclei. So what are the characters or the qualities of the stronger covalent bond? Substances with a stronger covalent bond must have high melting and boiling points and giant atomic structure. Like examples are diamond and graphite for this. Diamond and graphites are the macromolecules. They have high melting and boiling points, and they can contain many strong covalent bonds. Okay, they are also called macromolecular structures. And when we talk about macromolecular structure, when you want to break those structures, they need a huge amount of energy, and it is because of the strength of that bond actually. Okay. Now, if we comparatively see the extra diffraction of the covalent bond, you can see this is nucleus number 1 and this is nucleus number 2. Let me compare it with the with the ionic bond, and you will see that there's a big difference between the extra diffraction of the. See this.
Sir, are you sharing the screen?
Of course.
Can't see the screen.
You can see it right now?
Yes, sir, now I can see.
Okay, please, whenever you don't see the screen, maybe there's a fault in your browsing system, okay? Now you see the extra diffraction here. This is the extra diffraction for the ionic bond. Okay, see both the ions, the sodium ion and the chloride ions, they are separate from each other. But if you see this condition of the extra diffraction here in the ionic substances, in the covalent substances, you will see that the extra diffraction is totally different. See this one now. You can see the two nuclei, they are totally in a different way, and the electronic cloud is around the two nuclei, right? Are we clear with this?
Yes, sir.
Okay. So this is a sharing. This is an extra diffraction of the hydrogen molecule. It shows a high concentration of negative cloud, or charge between the nuclei and around the nuclei. This negative charge is strongly attracted by both nuclei. So a very attractive interaction, which is there are limitations for it. Like when you bring two nuclei close together, there is a bond length actually. At this bond length, the two nuclei are going to stop. Okay. going beyond the bond length, any close to each other, it will give them a repulsive force. So they are staying where the forces of repulsion and attraction both are balancing each other. In a covalent compound, there is a significant electron density between the atoms. Now we'll classify covalent compounds into two categories. The first one is the polar covalent, and the second one is the non-polar covalent. Now polar covalent, non-polar covalent, give you an example of that. Let me zoom in so that I can write and give you an example of that. We have hydrogen and hydrogen combination, a covalent bond between hydrogen and hydrogen, yani H2, this one. We have Cl2, we have N2, we have O2. These are called non-polar. I'll explain that to you. Now when we talk about non-polar, it means that the charge is exactly between the two nuclei, yani the shared pair of electrons are exactly between the two nuclei. Okay? So hydrogen is combining with another hydrogen. The two electrons are exactly here in between these two. The same is happening with oxygen, nitrogen, the examples which I've written there. So these two electrons are exactly in the center. So there is no side movement of charges. Like for example, if I take HCl, okay, HCl, hydrogen chloride, in which hydrogen is having one electron, chloride is having 7 electrons. So the combination will result in, this is hydrogen and this is chloride, dot and a cross will be there. So hydrogen is having 1 electron and chlorine is having 1, the dot is for chlorine, 2, 3 now, 4, 5, 6 and 7. I am counting this one also, okay? So 7 electrons are there. Now what do you think, where will be this shared pair of electron? Before it was exactly in the center. What was the reason for that? Why it was exactly in the center? Because both the sides were having same nuclei. Any nucleus of hydrogen is equal to another nucleus of hydrogen. There is one proton in hydrogen, there is one proton on the other side. So both are having same protons, plus one charge and plus one charge on the nuclei. So this bond is exactly, it's between, it's just like, you know, the arm wrestling between similar or same forces, same arms and the same people which are having same power. Like, okay, and then if we move on to the HCl, the nucleus of HCl is having 17 protons in it, and the nucleus of hydrogen is having one proton. So which one is attracting the shared pair of electron more towards itself?
Chlorine.
Chlorine is attracting it more. So the negative charge is more towards chlorine, and the absence of the negative charge is causing the positive charge. It will be towards hydrogen. So we will see that the shape will not be exactly the one which we have seen here, this one, not circular exactly. The two nuclei will not be like this. So how will be the shape? The shape will be something like this, where this area, which is where Cl is there, it is partially, this is called partially negative, and this area will be called partially positive, where the hydrogen is living. So you will find that the charge is like this. The electron density map is like this. Are we clear? This is for this is for polar. And the previous one, it was for non-polar. So non-polar happens between similar atoms and polar happens between different atoms when they are covalently bonded together. If you have any question, you can ask. Do you have any question? Okay, moving on to moving from this, on to how many types of covalent bonds are there?
2.
There are three types of covalent bonds: single covalent bond, double covalent bond, and triple covalent bond. Okay? When I'm defining a double covalent bond, first of all, the single covalent bond is when one pair of electron is being shared between the two atoms. One pair of electron is being shared between the two atoms, it's a single covalent bond. So single covalent bond, double covalent bond, single covalent bond is between the two atoms when one pair of electron is being shared. One is dot, the other is cross. A double covalent bond is when two pairs of electrons are being shared, like oxygen and oxygen. There are two lines, dot and a cross, dot and a cross. So this is a double bond. And triple covalent bond is when there are three pairs of electron, total of 6 electrons. So dot and a cross, dot and a cross, dot and a cross between nitrogen and nitrogen, sorry. Okay. So we have triple, we have double, and we have single covalent bond. In single covalent bond, the sharing of electron is one pair of electron is being shared between the two combining atoms, the non-metal atoms. In the double covalent bond, two pairs of electrons are shared. One pair of electron is total number of electrons are 2 electrons, 2e. Two pairs of electrons are 4 electrons, and three pairs of electrons are 6 electrons. Keep that in your mind. Sometimes they ask about pairs. Here 3 pairs, here 2 pairs, and sometimes they ask about the total number of electrons involved in it. Are we clear with that? So the main difference between the ionic and the covalent bond is that covalent bond is a sharing and ionic bond is a complete transfer of electrons. Yani one electron is losing the electron, the other electron is gaining the electrons. The other element is gaining the electrons. While in the covalent bond, there is no such loss and gain. There is always a sharing of electrons. If there is a 50-50 sharing, it's called covalent bond. If there is 100-0 sharing, it's called dative covalent bond. Yani in the cases which we have studied right now, single covalent bond, double covalent bond, and triple covalent bond, here the sharing is 50-50. 50-50 sharing is there. Keep this in your mind. But there are conditions where there is no 50-50 sharing. There are 100-0 sharing, and that is called dative covalent bond. What is dative covalent bond? A covalent bond in which one of the element is providing a pair of electrons and the other electron is providing its orbital only. Are you getting my point?
Yes, sir.
Yes, sir.
In the pure covalent bond, it's a 50-50 sharing. It's just like you and your friend are going to get KFC and now you're saying, okay, we both should contribute 50-50. So 10 dirham from your side, 10 from his side, 20 dirhams, and you got something out of it. But you went to someone's party, right, without taking any gift to him. So he's giving you party, everything, but you're just going there. You're showing your presence there. So dative covalency is one of the element is giving everything, yani the number of electrons is giving, but the other one just only the shell. Providing the shell, okay, you can accommodate them here, no problem. So the cases for dative covalencies are dative covalent bond, it is 100 0 sharing. One element is providing its shell or the orbital, and the other is providing electrons. Okay, are we clear with this?
Yes, sir.
Okay, now the examples. We need to understand these examples also. For dative covalency, the examples that are there with me, there are a couple of examples in your course, not more. And right now we have an example of H3O positive ions and ammonium positive ions. How these ions are existing. Water was HOH. There's a pair of electron and another pair of electron. Okay. Now this oxygen is going to offer that pair to the coming hydrogen, and hydrogen has nothing with it, just only it is having a nucleus. See this, the arrow is from oxygen side, and you get O with an H, H and H. A plus charge also, because extra charge is a plus that is coming from outside. So you get H3O in this case. In case of ammonia, you have nitrogen, which is already having hydrogen and hydrogen and hydrogen. Okay, and there is a pair of electron also. Now something is coming which is a hydrogen with a plus charge on it, and you get nitrogen with 1, 2, 3 regular bonds and 1 dative bond. Dative bond will be shown with an arrow and a bracket and plus charge on it. The same will happen to the water which I have shown there, here. Okay, one of the arrow, you need to draw the arrow and put it in a bracket and show a plus charge on it. Any question?
No, sir.
Okay. If you don't have any question, then I'm moving to my whiteboard screen, and I'll show you the structure once again so that we can simply work on those structures, okay? Because these structures are very important. So for the rest of 5 minutes, we will work on these structures. Okay. Let it be installed properly. I'm just waiting for it. Okay. We have the two ions separate from each other in the brackets with a plus charge on one of the ion and the other ion with the negative charge on it. Okay. If it is sodium chloride, then this is sodium ion and this is chloride ion. So this ion is going to be having a complete and a cross here. Both the ions are separated from each other. Okay. And the electron density mapping is telling us the story of sodium chloride, that if this is sodium, then this is chloride and NCl. Okay, this is electron density map. Clear? Now we work on the covalent and see what is covalent look, how does covalent look like. So for covalent, we have two types of covalent: polar and we have the non-polar as well. When we talk about non-polar, it was like hydrogen and hydrogen, where the shared pair of electron is exactly in the center. So the electron density map for this one is The two nuclei is exactly at the center, and non-polar ones like H with a Cl, okay, one is cross. This is a non-polar one. This one is polar one, sorry. And the electron density map was like this, a little bit louder, larger area. This is partial positive, which is showing hydrogen, and this is partial negative, which is showing chlorine, right? This is the electron density mapping. Then we classified the covalent substances into like pure covalent substances into three categories: single covalent bond, two atoms are close together, there's one dot and a cross. Then we have double covalent bond where oxygen and oxygen are combined together, dot, a cross, dot and a cross. And we have triple covalent bond in which nitrogen and nitrogen are brought together, dot and a cross, dot and a cross, dot and a cross. So how many electrons are there? Two electrons are there. 2e means two electrons. How many electrons are there? Four electrons are there. And how many electrons are there? Six electrons are there. How many pairs? Two pairs. How many pairs? Three pairs. Okay. And this is one pair. Any question? Then we talked about the dative covalent bond. Dative covalent bond is 100 0 sharing. Okay. In the dative covalent bond, the examples are H3O. How do we work on H3O? There's water molecule. Okay. How many pairs of electrons are there? Lone pairs. These are the electrons on it. It will offer one lone pair to the hydrogen positive, and it will make O with H, normal H, and dative H. This one is dative. Clear with this? Then we are going to move on to the Nh4 ion. In Nh4 with a plus charge on it, we'll have nitrogen with lone pair 1, 2 and 3. This is the hydrogen, combine it here, and this is the positive charge. Don't show it here, show the positive charge outside. Okay, so this is called dative covalent. The pair of electron is provided by nitrogen, and the shell is provided by shell, or the orbital is provided by hydrogen. So it's 100 0 sharing. Clear?